So, good evening everyone. Today, as you all know that we are here to basically analyze your chemistry paper. So, I have your paper right in front of me and it as such looks pretty easy. So, I also had a look at few previous year papers and the paper I think this year was quite easy. So, what we did was we actually went to a few schools and we sort of we interviewed quite a few students who came out of the chemistry who came out of the paper lab. And we asked them a few questions so that we can get the overview. So far I think it was good. People were happy because everybody had their happy faces on. So I think what students thought was that paper was really easy as compared to last year's paper. And if at all we have to compare some things, they said that basically it had more trickier questions as compared to the last year's paper. And they said they faced a lot of questions from organic chemistry. They had all organic reactions in the paper. So this was something that we had from the students' reaction. So later on we made and we have our own analysis, and to give you an overall sense of today's paper, this is what we have. So I think most of the students are going to secure marks in the range of 45 to 55. This is what we can think of, and this is what we have analyzed. So as far as I have got a look at the paper, I think scoring 45 plus should not be a big deal because paper was relatively easy. If you had covered all the concepts from the CBSE and if you had even read the concepts properly, I think paper was pretty straightforward. Even the numericals were pretty straightforward. And overall, the difficulty level for the paper was moderate, I would say, because it was not as easy, but it was not, once again, difficult as well. So it was a medium difficulty level paper, as of course we were expecting. So I hope you guys had a good time writing this paper, and I hope you all score well. So the course of this session is going to be like, what I'll do is I'll basically compare today's paper with last year's paper. Then I have some quick solutions with me. So basically, I'll give you the solutions for the very short answer question. So these are nothing but asking you IUPAC name and anything. The detailed solution of all the paper, of the whole paper, will be available on our website like very shortly. Our experts are already working on it. So stay tuned, but in this session, I will basically give you the solutions for the numericals and very short questions. So let's start. To begin with, I'll start with the comparison with last year's paper. So this is what I decoded when I had the first look at the paper. So I think the organic chemistry questions were very, very easy as compared to the last year. So this time they had pretty straightforward questions. And then last year, if you remember, surface chemistry had more of a theoretical question. They asked for definitions and examples and everything. But this time they had more of a conceptual question. They did not ask you the direct concept, but they basically asked you on the applications of those concepts. And again, level of numericals, I would say this time people emphasized more on numericals because the difficulty of numerical was something that I saw was on the higher level as compared to the last year. And as expected, last time my colleague Suyash had taken a live webinar on which sections you should concentrate on, and as he rightly had predicted, electrochemistry and P-block elements had the most coverage in your paper. So they asked total of 8 marks from electrochemistry, and from out of 70 marks they had almost 10%, that is 7 marks were from P-block elements. And apart from that, CBSE managed to touch all the sections from the CBSE books. So I think if you had revised the whole textbook thoroughly, I think you should have done pretty well in this question paper, and I think even you were having a happy face in the end. So let's begin with the analysis. I have 3 questions right in front of me. What I'll do is I'll quickly go through the questions. So the first question asked you to write the IUPAC name of the compound, right? So it was pretty straightforward, I would say, because this is a very simple compound to name. So the longest chain of carbon you can see is of 5 carbons that contains the ethyl group. The structure is given such that it is going to trap you into the thinking that C2H5, that is your ethyl group, is a substituent. But you need to make sure that it was not a substituent, it was a part of a main chain. so that we have a longest carbon chain, that is 5 carbon chain, and hence the name of the compound goes as 3,3 dimethyl pentane 2-ol. So that was the answer to the first question. It was once again a bit tricky but pretty straightforward. So moving on, second question was out of chlorobenzene and benzyl chloride, which is going to get easily hydrolyzed. So the second question mainly consists of the fact that hydrolysis basically takes place through formation of carbocation. So you need to make sure which compound is going to have a more stable carbocation. And of course it is chlorobenzene, because carbocation is more stable over there. In benzyl chloride, on the other hand, you have a primary carbocation, so it's not as stable as the cation in the case of chlorobenzene. Hence the answer for the second question is chlorobenzene. Moving on, they asked that the question of CO and H2. So CO and H2 actually reacts in presence of different catalysts, and they give you different products. This is a straightforward question from CBSE textbook. It is basically due to the selectivity of catalysts. So selectivity of catalysts is nothing but the property of catalyst by which they react differently to different. So even if you have same products with you, if you have different catalysts with you, you are going to get different products. This is basically selectivity of the catalyst. Hence, if you have different catalysts with you, even though the products are same, the reactants are the same, CO and H2, you are going to get different products because catalysts have a selectivity property. Hence, answer to this was selectivity. Fourth question was to find out the coordination number and oxidation state for platinum in the given complex. It's again a very straightforward question because the complex is pretty simple. The oxidation state for platinum comes as +2 and coordination number comes as +6. Moving on, question 5 was basically on the non-stoichiometric composition of FeO. Now this is once again straightly from the NCERT textbooks. It's mainly due to metal deficiency effect. So synthesis of not all metal oxides is very easy. So what happens is at times you get different stoichiometry. You don't actually get the stoichiometry you are aiming for. So that exactly what happens in the case of FeO. You don't have all 2+ ions of Fe. In fact, at some place you get Fe3+ ions. So your charge is balanced, but only 0.95 fraction of all Fe is Fe2+. So the answer to this basically was metal deficiency effect, because of which you get this non-stoichiometric composition of FeO. So then sixth question was to basically complete and balance the reactions. So it was a pretty fundamental question. The A part basically was a reaction that was happening in acidic medium because it had H+ in it. And the another one was it had H2 in it, that means it was a neutral medium. So for acidic medium, that is the A part of the question, 6th A. In acidic medium, the reaction goes like 5 Fe2 plus MnO4 minus plus 8H plus gives you Mn2 plus 4 H2O plus 5 Fe3 plus. So here basically your overall charge is going from, so the oxidation state is changing from +7 to +2, and the 6th B, that is the reaction that is happening in your neutral medium. There the reaction, the balanced reaction goes like this. 2 MnO4 minus plus H2O plus I minus gives you 2 MnO2 plus 2OH minus plus IO3 minus. So this is the balanced reaction in the neutral medium, and this was basically the answer to your 6th question. Now what I'll do is, this was your short answers, so I could quickly tell them, all of us. I also told you how to arrive at these answers. So it was pretty easy. Now let's move on to the numericals. What I'll do is, I'll quickly go over all the numericals that came into your paper, and I'll give you answers to all of them. So yeah, the 8th question itself was a numerical which asked for the rate of disappearance of N2O5. Now, it is a pretty fundamental relation that 1 upon stoichiometric coefficient into the rate of appearance or disappearance, depending on whether it is a reactant or product. You can find the answer to this question. So if you are already been given the rate of formation of NO2, so rate of disappearance of N2O5 comes out to be 1.4 into 10 power minus 3 molar second inverse. So this is basically the answer to the 8th question. It is pretty straightforward. All you have to do is to make the use of a fundamental relation that says 1 upon stoichiometric coefficient into rate of appearance or disappearance of a particular species are same for a given reaction. Moving on, you have the question number 10 that asked you to calculate the freezing point of a solution containing 60 grams of glucose into 50 grams of water. This was once again a very straightforward question because all you had to do was calculate the molality. Molality is nothing but number of moles of glucose per kilogram of water. You get the molality. Once you get the molality, you can easily calculate the depression and freezing point. Once you get the depression and freezing point, you can calculate the freezing point. So depression and freezing point, as per my calculation, turns out to be 2.48 kelvins, and hence freezing point will be 270.52 Kelvin, because as such freezing point is 273 Kelvin for water. So depression is 2.48, giving us 270.52 Kelvin as the actual answer to this question. 11th question was once again numerical. So it had given us that we have an FCC structure. Then they gave us the parameters, that was edge length was 400 picometers, and and the weight basically was given to be 4 grams. It is once again a very similar formula because all you have to do is calculate density from the relation that is Z into M divided by A cube into Na. So if you just simply substitute the formula and you make sure that you convert picometers into centimeters because you are going to report density in grams per cubic centimeter, you can easily get it because it is nothing but a substitution in your formula, and the question turns out to be, the answer turns out to be 4.15 grams per cc. Moving on, the question is question number 28, which was once again a numerical, and the question said that it talked about a first order reaction which gave us the half times at different temperatures. This was, I would say, more of a tricky question because here it is important for us to realize that a rate constant for a first order reaction is inversely proportional to time. So you basically have K inversely proportional to T. And then what you do is you have times for basically 2 different rate constants. All you have to do is take the ratio of that. So basically K1 upon K2, if K1 is the rate at temperature T1 and K2 is the rate constant at temperature T2, what you can do is K1 upon K2 is equal to T2 upon T1 because they are inversely proportional to each other. Once you have arrived at this relation, all you have to do is make use of Arrhenius equation in order to substitute for K2, and simply it's the mathematical construct. You have to keep on solving and solving until you get the answer. So I have solved it and I've got the answer for activation energy as 27.66 kilojoules per mole. So make sure you solve it, and I think this is the correct answer. So make sure you get, if you have not got it in the question, this is how you do it. So, and the answer comes out to be 27.66 kilojoules per mole. The final numerical of the paper was based on electrochemistry. Electrochemistry question had us to calculate the EMF of the cell. So if you have attempted the A part, like the first part of the OR, the EMF for the given cell turns out to be 0.1105 volts. And for the other part of the OR question, if you are attempting to calculate the EMF of the cell, your E cell turns out to be 0.351 volts. So these were basically the answers which you get for the numericals in the paper. The analysis once again is mainly on the numericals. If you want to look at the actual solutions, the whole solution to this paper is going to be up on our website pretty soon because the experts have almost finished writing the solutions for them. So they'll be up pretty soon. What happens is at times you might get pretty nervous in exam time and you might mess up the calculations, and because of that you might get the answers wrong. So make sure even if the answers don't match up with the answers which I gave you just now, you solve it again. And I think I have taken proper care to arrive at the right answer. So this should be it. I have given you almost all the answers that I can give you right now, and I'll take question and answer session right now. So I have the first question with me, which says structure of HClO3. Sanjay Kumar is asking this. So Sanjay Kumar's structure of HClO3 is nothing but you have Cl as your central atom. You have 2 double bonded oxygen to it and 1 OH to it to give you the whole structure of HClO3. Now, since this is a live webinar, I won't be able to draw it in front of you, but it is basically 2 double bonded oxygens to a central chlorine atom and 1 OH group attached to chlorine atom as well. So this was it for Sanjay Kumar. And well, people are asking me to compare the difficulty level of numericals in previous year. So what I would say that, let's just say the people who are asking me this question, you needed your scientific calculator to work better in this exam than the previous year. Because this time, the numericals were more cumbersome in a calculation way. Like I gave you the calculations for different things, I gave you the direct answers. But arriving at those answers were cumbersome because it involved a lot of complicated calculations. Those calculations were straightforward, but then very cumbersome figures make it very difficult for us to solve. So yeah, I think that answers your question. The difficulty level was definitely higher, but just the calculations were a bit cumbersome. Then I have Ritesh Prajapati asking for XCF4 structure. So once again, this is a kind request to all the users. Make sure you ask doubts which I can explain you properly, since this is a live webinar. I won't be able to explain you the structure properly. So once again, I'll have to tell you the bonding of the structure. I cannot draw the structure right in front of you. I think you will be able to see this once all the solutions are up on our website, and it would be much clearer to you then. So Abhishek Moitra is asking me, sir, how much marks I'll get for a question if I have not written the exact answer but correctly written the concept behind it. Abhishek Moitra, I think this is the question that many students might be having in their minds. So good that you asked this. I would say that CBSE 12th, the best part of this examination is you get marks for your steps. So even if you have, suppose you have a numerical for 5 marks, and suppose you have got the concept right, but you are not able to get the calculations right. As I told you, that calculations were very cumbersome in this paper. So if you are able to get the concept right, I'm pretty sure the moderator is going to give you at least 2 marks for it. And even if you have not got the exact answer right, and you have proceeded to the right steps for the calculation, I think you should be able to get approximately 3.5 and 4, because 1 mark is definitely awarded for the correct solution. So if you have done the calculation steps right, I think you should be able to get until 3.5 and 4 out of 5. So I think that answers your question. Then I have another question. Why is biethanol added to soap? And this question has been raised by Sanjay Kumar. So to answer your question, Sanjay, biethanol is basically added to impart the antiseptic properties and to reduce the odor that is produced by the bacterial decomposition of organic matter on the skin. So basically what happens is when we apply soap on our skin, it starts acting on it, and it has different antiseptic, because what happens is many times you might have some cuts on your body or on your skin, and if you apply soap at it, you need to make sure that you don't get harmed by it. And it is for this reason we add biethanol, so that it imparts some antiseptic properties to it as well. Then I think Shailesh Kumar is once again asking what happens when emulsion is centrifuged. When emulsion is centrifuged, what happens is, so emulsion is basically a homogeneous mixture. It is being held together by a, the surfactant. So when you centrifuge emulsion, you're not going to get anything because it is a homogeneous mixture. In order to precipitate or in order to separate the components of a centrifuge, what you have to do is you have to change the pH of the emulsion or you have to add acid to it. What happens is, once you add acid or once you change the pH of the solution, you have a surfactant with you, right? You have two different charges on it. You play with the charges so that the two phases which are being held together by a surfactant are then disturbed and you get precipitation of one phase or the other. On centrifugation, you are not going to have anything. So nothing happens when an emulsion is centrifuged. So I hope that answers your question. And Sai Kumar is asking, is it possible to use magnetic field as a fuel? I don't think, Sai, your question is clear. Can you please reform it in such a way that I can make some sense out of it? Or probably tweet it through Tesla. He might be a better judge of it. And Ritesh Prajapati is saying polysaccharides, sir. So Ritesh, what exactly do you want me to tell about polysaccharides? There are a lot of polysaccharides around us. So if you're drinking tea right now, the sugar in it is also a polysaccharide. It is basically a carbohydrate whose molecules consist of a number of sugar molecules that are bonded together. Well, I think this was my basic understanding of chemistry paper today. The chemistry paper was more or less as we had expected, and if you had followed the previous seminar from Suyash, I think you should have done a much better. I think you should have been able to score at least 50 plus if you had properly listened to what Suyash had said. So I would advise you that you listen to Toppr webinars more often, because we do a very structured and a very comprehensive analysis of the previous year papers. We study them thoroughly and then we arrive at some analysis. And that's why we are hosting these webinars, so that you get more understanding and you are able to predict the questions in your question paper better. So if you actually can see that Suyash had exactly predicted the 60% of this question paper right. So if you had focused on the chapters which he told you to focus about, I think you would have got like more than 70% in your today's paper. And which one is a trickier numerical question in the exam? So I would say the one on the electrochemistry was the most trickiest one, because there I myself had to think for a bit to get around the solution. And I think the electrochemistry question, basically the second part of the OR, that was the more trickier one. I think that's what is your question, so I think that answers your question. Pradyut Banerjee is asking, what is anti-ferrocoupling? I think, Pradyut, you have some typo over there. Can you make sure that you type your question right so that I can answer it properly? And Ritesh, I think I've answered this. Okay, so keep on bringing questions. Till then, what I'll do is I'll also tell you how far. So what happens is we go around and we keep a survey online. So we keep receiving responses from people all the time, and so far, currently, I can see that maximum of people are saying that they are going to score somewhere between 45 to 55. So this is what is their prediction. They are saying that they prepared it well, but seeing all the reactions, they got a bit confused. So they are saying that out of 70, they might be able to get around 55. And there is a guy who is saying that he's pretty confident that he'll get 60 plus because he had covered almost all of it. So I guess all the best, Rishabh. I hope whatever you're saying comes true. And let's see. So FEOH. So Ritesh, I think this was Ritesh. No, Shailesh Kumar is asking what happens when FeOH thrice is mixed with FeCl3. Okay, once again, Ritesh, I would sort of advise you guys to ask me questions such that I'm able to explain it just orally, because once again, this question involves reaction and everything. So I would say that whenever you have a freshly prepared FeOH price and it is shaken with say FeCl3, you get a reddish brown solution of FeOH price. And to write the reaction for it, what you have is FeCl3 basically gives you Fe3 plus ions, and these Fe3 plus ions when react with FeOH price once again gives you a colloidal solution where Fe3 plus ions from this FeCl3 are adsorbed onto the surface of the precipitate, and hence we get a colloidal solution and we have a positively charged solution. So I hope that answers your question, Shailesh Kumar. And then I have another from Britesh Prajapati. Mass decreasing. Okay. Before that, I have one more question from Sai Kumar. Sir, mass decreasing materials for car like nano materials are outed or not? Sai Kumar, once again, I would like to ask you. Your question is not very clear. Can you please elaborate it a little so that I can answer it properly? I'm not able to make anything out of if NST materials are outed or not. Please explain your question properly. Okay, next up I have a question from Ritesh Prajapati. He is asking if amino acids show amphoteric behavior or not. And if they do, why? Okay, so Ritesh, I think chemistry paper is done, but still I'll answer your question. The amphoteric behavior of amino acid is basically presented in its aqueous state. So what happens is, in an aqueous solution, you have a COH group in your amino acid. It can lose its proton, and then amino NH2 basically present in the amino acid can accept a proton. So you basically have plus sign, plus charge, as well as negative charge in your molecule, so that you get a zwitter ion. And once you have a zwitter ion, I think it can exhibit both acidic as well as basic properties, and hence amino acids are able to show amphoteric properties. Ritesh Prajapati is once again asking define a denatured protein. So protein as such, so what is protein? Protein is something that has a primary structure, secondary structure, and a tertiary structure. And it is due to different mechanisms. You have disulfide linkages, you have hydrogen bonding, because of which you get primary structure, secondary, or a tertiary structure. And what happens is, when you add a denaturing agent to a protein, these structures get distorted because they disturb the forces which are basically forming up these structures. So denature of proteins basically involves the disruption and the destruction of both secondary and tertiary structures of the protein. And since the denaturing agents that we use in our daily lives, in our industry, they don't break the peptide bonds, and hence we can see that primary structure is as much as intact, and only secondary and tertiary structure gets disrupted in the denaturing process. Then, once again, ethical hacker Anish is asking, please say what is meaning of MOD. Okay, ethical hacker Anish, I think you need more hacks into your English. Can you please tell me what is the meaning of MOD? I cannot make anything of your question. I think you are asking what is the meaning of MOD, but what is MOD? Like, I have no clue what you're talking about, so please elaborate your question properly. And Bragg spectrometer. I think, what is this? I think this is the wrong place to ask this question, Alexander. I think Alexander. So Bragg spectrometer is not something we deal with in the 12th standard CBSE chemistry. So I think, why don't you do it? Why don't you go to a DOC app and ask this question? We'll answer it over there. Then define electrolysis. So I'll tell you this, electrolysis, the term itself has lysis in its words. So lysis is nothing but breaking down something. So electrolysis is basically breaking down a component when electric current is passed through a solution. You basically carry out a decomposition of a particular compound, and that process is known as electrolysis because you're breaking down the compound by making the use of electric current. So from electric current you get electron, and from decomposition you get lysis. So that is electrolysis. So chemical decomposition produced by passing the electric current through a liquid or an ionic solution. Through a liquid solution. Well, then question. I'm sorry. Okay. I think question 6, I'm being asked to repeat the question number 6. So question number 6 asked you to balance the reactions and also to complete it. So I would say 6 questions A part was a reaction that was happening in an acidic medium. So Fe2 plus MnO4 minus plus 2H plus. So this reaction, balanced and complete reaction, is as follows. It gives you 5 Fe2 plus MnO4 minus plus 8H plus gives you Mn2 plus 4H2O plus 5 Fe3 plus. And this question B, this B part of the 6th question, had MnO4 minus plus H2O plus R minus. Since you have H2O over here, this is basically a reaction happening in neutral medium. And you can see the reaction happens like this. 2 MnO4 minus plus H2O plus R minus gives you 2 MnO2 plus 2OH minus plus IO3 minus. So these are the two balanced reactions for the question 6. And I think that answers your question. And next up, I think okay. So reducing agent. Nupur Srivastava is asking arrange to decreasing order of reducing agent. So Nupur Srivastava, what I'll ask you the best way to do is, see, you look at this way. What you do is you have standard reduction potentials given to you. Standard reduction potential is nothing but a tendency of a particular atom to get in order to get reduced. So lower the standard reduction potential, lower is the ability to get reduced, and hence you can compare the reduction potentials for HF, HCl, HBr and HR, and thereby come at the order of the reducing agent. Important point to note over here is the one which is going to have lower reduction potential. That is, it is very less susceptible to undergo reduction. That is, it is not so willing to give to accept electrons. Reduction is basically you're accepting electrons, right? So if you have less reduction potential, that means it is not very willing to accept electrons. That means it is willing to give electrons. Now once you give electrons, you basically cause reduction of some other species. That is, you are acting as a reducing agent. Hence, the decreasing order of reducing agent will be the decreasing order of oxidation potential of this species. And reduction potentials, if you arrange basically the species in increasing order of reduction potentials, you will get decreasing order of reducing agents in this species. So I think this answers your question, Rupert. So I think this answers most of your queries, and this also concludes the analysis of CBSE chemistry question, CBSE standard 12th paper on chemistry, which happened today afternoon. I hope you all had a great time solving this question and you guys got most of the answers right. The solution is going to be there on our website very, very soon. So make sure you stay tuned. Make sure you subscribe to TopprLive on Facebook, Instagram, and whatever social media site you come across, so that you are in line with all the helpful webinars that we conduct from time to time. To conclude, I'll take this last question from Salim Sheikh, who is asking what is a carboxylic acid. So carboxylic acid is basically an acid that has a carboxyl group, that is COOH. The very easy examples are acetic acid, that is CH3COOH, or a formic acid, that is HCOOH, HCOOH. So basically whatever compound that has, whatever aliphatic compounds that contains dash COOH are your carboxylic acids. So thank you for joining me for this webinar. I hope this analysis was helpful to you, and good luck for your next exams, and I hope you guys did a really good job in today's chemistry paper. So see you again next time. Stay tuned.